Good afternoon, everyone. Welcome back to Now I Know. I'm Lance Marvin Huya, your host. So for today's episode, we will be talking about predicting products and balancing chemical equations. Sounds interesting, right? So without further ado, let's get learning. Before we go to our main topic, let's first find out what is a chemical reaction. Jampol, do you know something about chemical reactions?
Of course, a chemical reaction is a process in which the properties of the original substance change into new substances with a different in physical chemical properties. Examples of these are fireworks, lighting a match, and even the process of digestion in our stomach. We can say that a change is a chemical reaction if we observe this evidence. Example number 1, change of color. Number 2, formation of gas. Number 3, temperature change. Number 5, change in smell. And 5, formation of precipitate.
Andrea, do you want to add any information?
Yes, a chemical reaction has two parts, the reactant and the product. Reactant is a substance or a group of substances which enter a chemical reaction. Meanwhile, product is a substance or a group of substances that are produced in a chemical reaction. For example, in cooking pork adobo, the ingredients are the reactant and the pork adobo itself is the product. But the difference is that in cooking, there are many ingredients but only one product. In chemical reaction, it's possible to have many reactant and one product, one reactant and many products, also many reactants and many products. That leads us to our first topic, predicting products. Predicting products of chemical reaction requires you to know how to write the formula of compounds and the types of chemical reactions.
Elijah, Angel, and Sharifa, can you explain the types of chemical reactions?
Sure can. There are 5 types of chemical reactions. The first type of a chemical reaction is synthesis, or combination reaction. It occurs when 2 or more substances are combined and form a compound. The general form for this chemical reaction is A and B react to form AB. A and B on the left are the reactants, while A on B on the right is the product, and when it combines it forms a compound. Examples of this are sodium and chlorine react to form sodium chloride. Ammonia and hydrogen chloride react to form ammonium chloride.
The second type of a chemical reaction is decomposition reaction. It occurs when a single compound breaks down into 2 or more simpler products. The general form of this chemical reaction is AB react to form of A and B. AB is the reactant while A and B on the right are the products. Examples of these are hydrogen peroxide react to form of water and oxygen gas. Zinc carbonate react to form of zinc oxide and carbon dioxide. The third type of a chemical reaction is single displacement or replacement. It occurs when one element replaces another element in a compound. The general form of this chemical reaction is A and BC react to form of AC and B. A and BC are the reactants while AC and B are the products. Examples of these are hydrogen chloride and zinc react to form of zinc chloride and hydrogen gas. Bromine and potassium iodide react to form of potassium bromide and iodine.
The fourth type of a chemical reaction is double displacement or replacement reaction. This involves exchanging of ions to form new compounds. The general form for this chemical reaction is AB and CD reacts to form AD and CB. AB and CD are the reactants while AD and CB are the products. Examples of this are barium chloride and sodium sulfate reacts to form barium sulfate and sodium chloride. Potassium bromide and silver nitrate reacts to form potassium nitrate and silver bromide. The fifth and last type of chemical reaction is combustion reaction. In a combustion reaction, the fuel reacts with oxygen and produces similar products, carbon dioxide and water. The general form for this chemical reaction is fuel and oxygen reacts to form carbon dioxide and water. Fuel and oxygen are the reactants, while carbon dioxide and water are the products. Example of this is methane and oxygen reacts to form carbon dioxide and water. Keep in mind that regardless of the type of reaction involved, It is important to remember how to write the formula of the substances in the products correctly.
What an overwhelming information! My brain cannot function already. Just kidding. For us to better understand the lesson we're going to learn today, let's first find out what is law of conservation. Daniela, can you please tell us what is the law of conservation?
Oh, sure. Law of conservation tells us that matter is neither created nor destroyed. In any chemical reaction, the total mass of the reactants must be equal to the total mass of the products. To understand more about law of conservation, we need to be able to identify first the reactants and products in a chemical equation. Let's use photosynthesis for example. During photosynthesis, plants take in carbon dioxide and water from the air and soil. Within the plant cell, the water loses its electrons, while the carbon dioxide gains electrons. This process transforms the water into oxygen gas and the carbon dioxide into glucose. Water and carbon dioxide will be the reactants, and oxygen gas and glucose will be the products. So to write this into a chemical equation, it will always be reactant plus another reactant reacts to form product 1 plus product 2. That's carbon dioxide and water reacts to form glucose and oxygen.
Whoa, my mind is so fascinated right now. Now, let's go to our main topic for today. Kim and Andrea here will explain to us how to balance a chemical equations.
Before we can identify if an equation is balanced or not, we need to study the anatomy of a chemical formula. For example, carbon dioxide. The red number is called a coefficient, while the blue number is called a subscript. Take note that the coefficient is always an integer or a whole number, and then the subscript is also an integer but is 1. If there is no subscript, automatically it's 1. If we are going to count how many atoms carbon and oxygen have, the subscript is the number of atoms of the element beside it. So carbon is 1 and oxygen is 2. Then you will multiply the coefficient to the subscript. So carbon is 3 times 1 equals 3, and oxygen is 3 times 2 equals 6. Another example is magnesium nitrate. We have 3 elements here. That's magnesium, nitrogen, and oxygen. Let's first focus on the subscript. So the subscript of magnesium is 1, nitrogen is 1, but it's inside a parenthesis, and there is 2 outside. So we need to multiply it. Nitrogen is 1 times 2 equals 2, and then oxygen is 3, and then multiply it also to 2, so that's 3 times 2 equals to 6. After that, you will multiply the 3 to the subscript of each element. That's magnesium, 3 times 1 equals 3. Nitrogen is 3 times 2 equals 6, and oxygen is 3 times 6 equals 18. It's quite hard, but when you get the hang of it, it's really easy.
Now let's learn how to balance a chemical equation. In order to balance a chemical equation, the reactants and the products of each element needs to be equal or same. Let's use this chemical equation as an example. Methane and oxygen yields carbon dioxide and water. First, let's count the reactants. So carbon has 1, then hydrogen has 4, and oxygen has 2. Next, let's count the products. So carbon has 1, then hydrogen has 2, and oxygen has 3. Now to balance it, we need to add a coefficient. Keep in mind that it's not necessary to add coefficient to all molecules. If you balance it and there are 1 or 2 molecules that does not have coefficient, it's okay. It means the coefficient of it is 1. For you to balance an equation easily, focus on one element that you think you can do trial and error. For me, I think it's hydrogen. So let's start with hydrogen. So let's add 2 as a coefficient in the product of hydrogen. Then multiply 2 and 2. That's 4. So now both reactants and products of hydrogen is equal. The 2 that we add in hydrogen can also affect oxygen. So that's 2 times 1 is equal to 2. And 2 times 2 is equal to 4. Now let's go to the reactant of oxygen. Let's add 2 in the reactant of oxygen. So that's 2 times 2 is equal to 4. Now both reactants and products of oxygen is also balanced. Carbon 1 and 1. hydrogen 4 and 4, and oxygen is 4 and 4. So the balanced equation is methane and oxygen yields carbon dioxide and water. That's it.
Wow, I think I'm a scientist now. Just kidding, at least now I know. That's it for today's episode of Now I Know. Stay tuned for more upcoming videos. Thank you all for watching. Bye!